Assalamu alaikum students. Today we will practice the questions of paper 4 2000 of October 2025 third variant, and as we are covering some selected topics, so we'll switch on and we'll jump straight to those questions here, starting from question number 2, question 3, B part, and here the third subpart. State the oxidation number of zinc in Zn2 plus and Zn. So we need to understand that whenever we have the atom along with a charge on it, if it is just one atom along with the charge on it, then that charge will also represent its oxidation number. So Zn with 2 plus charge will have a charge of 2 plus on it. So this is the oxidation number. And in the second case, the Zn does not have any of the charge mentioned here. That means its charge will be 0. Its charge will be 0. Do not incorrectly state +1 because +1 will definitely be an ion. It is not an ion. So its charge will be, or its oxidation number will be 0 here. Then part 4, define the term reduction in terms of the oxidation number. So reduction in terms of the oxidation number is basically a decrease. We remember there are 4 different ways to express the oxidation or reduction. One of that is the oxidation number or oxidation state. Both mean the same thing. So in terms of oxidation number, we will say a decrease in oxidation number. Decrease in oxidation number or state. Both will give you the same answer. That is representing the reduction. And then C part, aluminum reacts with the iron 3 oxide. The equation is shown. We have this equation. Along with that, we have the delta H mentioned for this reaction. Now, delta H sign is also given, which is negative. That means we have to express your answer in accordingly. Part 1 says state the meaning of the symbol delta H. So delta H, if you remember, it represents the enthalpy change. It's better to write enthalpy change instead of writing the heat change. Do not write the heat change, just write the enthalpy change. Because heat will be represented as Q when you will study this chapter in AS. In AS, you will be confronted by this term heat, which is represented by the letter Q. So enthalpy change, on the other hand, has a enthalpy sign of delta H. And then state what can be deduced about the reaction from the big negative sign in delta H, which is minus 850. So the negative sign, as you remember, it tells that enthalpy of reaction is exothermic. Enthalpy of the reaction is exothermic. Or if you just state that reaction is exothermic, that is also fine. And one more thing, if the delta H is negative, it is representing for the reaction when you are moving from reactants to the product side, which means it is representing the forward reaction. For forward reaction, the reaction is exothermic. And you should keep in mind that if we tell about the backward side, then the backward reaction will be endothermic. backward reaction is endothermic and the forward reaction is exothermic. D part must be skipped, that's not included. E part is also excluded. F as well. Then we'll move on to the question number 4. This question is about the it is actually about chlorine and compounds of chlorine. Gaseous chlorine reacts with a gaseous phosphorus chloride to form the gaseous phosphorus 5 chloride. The reaction is a reversible reaction. When the three gases are in a closed container, the system reaches equilibrium. Cl2 plus PCl3 produces PCl5. Describe a reversible reaction at equilibrium in terms of the rate of the forward reaction and the rate of the reverse reaction. So we have to express what do you find in the equilibrium reaction. In the equilibrium reaction, we remember that the rates of both the forward as well as the backward reactions are same or equal. Rates are equal. So reverse reaction means backward reaction. So we say the rate of forward and the backward reactions are uh, equal because the question is asking you to express the rates. It is not asking you to write the whole sentence again. You will not be given any credit if you just write the rate of the forward and the reverse reaction. If you write all these words again, you will not be given a single credit. So your answer must be according to the question, what they are asking you to write, what they are demanding for you to give the answer. You just need to tell the rate of the forward and the rate of the reaction are equal. That's it. Uh, Students, I will suggest you all to go through the command words. Command words tells you what you need to write in your answer. The words like describe, and then there are some other words associated at the present at the start of the reaction. Present at the start of the question, like write, state. These are all the command words. So if you just go through the command word in detail, you will be easily able to write the correct answer or the answer required by the examiner. So then next point is describe a reversible reaction at equilibrium in terms of the concentration of reactants and products. So you have to read in this single prose. Concentration of reactants in an equilibrium reaction, they are similar, or you can say they are same. They are same. Sorry, not same. Not same. They are constant because there's a difference here. If you write same, then it would mean that both reactants and products have equal amount, but that is not correct. Reactants and products is not necessarily having same amount exactly. Instead, they could have different amounts, but they will not be changing. You can write they are constant or they do not change. Then next part is about a table. Complete table 4.1 using only the words increases, decreases, or no change. So you have to write only these words in the table. We have first column about change to condition. What kind of change they are applying? They are applying the pressure and a catalyst use. So if they apply the pressure and the pressure is decreased, like they are changing the pressure by decreasing it. So what will the effect on the rate of the forward reaction? Now, for this purpose, you have to refer to the chemical equation. This is a chemical equation, and we remember pressure is related with the moles. pressure is relative to the moles. So according to this, we have 1 mole of Cl2, 1 mole of PCl3, and 1 mole of PCl5. So in total, we have 2 moles in the reactant side and 1 mole in the product side. So pressure, if we remember, if we decrease the pressure, then equilibrium will shift in that direction which has more number of moles, which are in the reactant side. So effect on the rate of the forward reaction, which means towards the product side, we can simply say it will decreases, because we have to write exactly the same word, decreases. So by decreasing the pressure, the forward reaction will decrease because equilibrium has to shift to the reactant side, and reactant side means backward reaction. So the question is demanding you to write the rate write the effect on the forward reaction, and then the effect on the equilibrium concentration of the PCl5. So what is the effect on the concentration of PCl5? We again see PCl5 is basically the product here. So in a similar way, we can tell that if we decrease the pressure, then equilibrium is shifting towards the reactant side, not towards the product side. That means the equilibrium amount or the concentration of the PCl5 will again be said to be decreased. So it decreases. I hope it's clear to everyone, because we have just understood from the logic that decreasing the pressure must shift the equilibrium towards the reactant side, and if it is moving towards the reactant side, then concentration of PCl5 will decrease. It will decrease. Then second row is about a catalyst. Catalyst is added. So we remember, if a catalyst is used, then the rate of both the forward and the backward reaction increases, and they have already filled the first field here. We have to tell what would be the effect on the concentration of the PCl5. So with respect to this, the concentration of the PCl5 will not change. The reason is that we are basically increasing both the forward reaction by using the catalyst as well as the backward reaction. Both are increasing in a similar way, in the same rate. So if it is changing in both ways by the use of the catalyst, then concentration of the PCl5 would not be altered. It will not be changed. But now we have to use exactly the word as mentioned in the question. The question says, write the word no change. So you have to very precise, be careful while writing your answer. So write the same word here, no change. Then part 3, when the temperature of the equilibrium mixture is increased, the equilibrium concentration of PCl5 decreases. State what conclusion about the formulation can be made from this information. Now, if we look back at the equation, they have not included the symbol of the enthalpy change. There's nothing about the enthalpy change over here, which means you have to calculate by yourself what will be the effect of the temperature. Yeah, they have already explained you the effect of the temperature in this one condition. The temperature is increased and concentration of PSL5 has decreased. So PSL5 decrease means the equilibrium has shifted towards the reactant side. If the PSL5 is decreasing, it means the equilibrium is shifting towards the reactant side. So what is the relation of the temperature with the enthalpy here? Temperature relation with the enthalpy. If we are increasing the temperature and equilibrium is shifting toward the reactant side, it would mean that delta H of this reaction is exo. Delta H of this reaction is exo. That is why it is shifting towards the reactant side. And also write the forward word here. Forward reaction is exothermic. If you do not write forward reaction, it is still understood because they have already specified it is for the forward reaction. So just exothermic is also sufficient. Then P part. Ethene reacts with chlorine to form 1,2-dichloroethene. The equation for the reaction can be represented as shown. We have this reaction. Use the bond energies in table 4.2 to calculate the enthalpy change in kilojoule per mole of the reaction. Use the following steps. Calculate the total energy needed to break the bonds in C2H4 and Cl2. So we are supposed to find the bond energies of the whole reaction, but for that answer, we need to calculate its multiple parts. The first part is about bond energy needed to break the bonds in C2H4 and Cl2. Now, we'll look at the formula, the C2H4. So here we have one carbon-carbon double bond and four CH bonds. So carbon-carbon double bond plus 4 times of the CH bonds. So if you calculate the value, carbon-carbon bond is equal to 610 and CH bond is equal to 410, which means 4 times 410. If you calculate the value from the calculator, you will get 2490. 2490 for the reactants. Now the value for the product side. Calculate the total energy release when the bonds form in CH2Cl, CH2Cl. Now use the values from here. We have CH bond equal to 4 times of the CH, just like previous case. Plus we have C bond. Plus we have 2 bonds of the C with Cl. There are also 2 bonds of C with the Cl. So use the value from that table for C with Cl. Plus 2 times of C bonded with the Cl. So it is equal to 410 times 4 plus CC bond is 350 plus 2 times of C with Cl bond, this one, 340. We had to include the value of the Cl bond with the Cl as well over here. So Cl bond with Cl is 240. Cl with Cl is 240 and C with Cl is 340. 240 over here. That gives you 2490. And if you calculate these values, you get 2670. Now you have the values of both the reactants and the products. Now the third point, calculate the delta H. So we remember delta H is basically calculated as bonds broken minus bonds formed. So broken value is equal to 2490 and bonds formed is 2670. So take the difference and you will get equal to minus 180. So 180 is the answer. All right, let's continue. C part is to be skipped. D part is also skipped. No, not completely. D part 1 to be skipped, but not 2. I will read from here. When solid magnesium carbonate is added to dilute hydrochloric acid, a chemical reaction occurs. The equation for the reaction is shown. Part 2 says, calculate the volume in cm cube of the carbon dioxide that is produced at room temperature and pressure, RTP. Room temperature and pressure is abbreviated as RTP. When 50 cm cube of 0.1 mole per dm cube HCl react with excess MgCO3, the volume of 1 mole of any gas is 24,000 cm cube at RTP. Use the following steps. Calculate the number of moles of the HCl in 50 cm cube of 0.1 mole per dm cube HCl. So here we have the volume and this is the concentration. We have to find the number of moles. The simple formula is N is equal to C into V over 1000. So C is equal to 0.1, volume is equal to 50 divided by 1000. So it is equal to 5 over 1000. It is 0.005 mole. 0.05 mole. Then next point, reduce the number of moles of carbon dioxide gas produced. So for this purpose, you have to look at the chemical equation. According to the chemical equation, we have just calculated the number of moles of the HCl, which means you can use a ratio method to find the moles of the carbon dioxide. So HCl ratio carbon dioxide. If there are 2 moles for HCl, there is 1 mole of carbon dioxide according to the balance equation or according to the stoichiometry value. And we have just calculated the moles of the HCl to be 0.005, and for carbon dioxide becomes X. So cross multiplication, X is equal to 0.005 divided by 2. So we calculate this value. The answer is 2.5 into 10 raised to the power minus 3, or 0.0025. So 0.0025 is the mole of the carbon dioxide form. Then calculate the volume in the cm cube of the carbon dioxide produced. According to the statement given here, 1 mole has 24,000 cm cube. So simply write here 0.0025 times 24,000. Because if 1 mole is equal to 24,000, then 0.0025 will have value equivalent to 60 cm cube. So 60 cm cube of the gas is produced. We leave the question 5. That's not included. Then question number 6. Yes, question number 6 is included. That's also included, which is related to empirical formula calculation. Carbon is 50%, hydrogen is 5.56%, oxygen is 4.4%. To find the value of the empirical formula, so it's simple. Yes, first of all, take the percentage as a mass of the car of these elements: carbon ratio hydrogen ratio oxygen. 50 is the mass of carbon, 5.56 the mass of hydrogen, and 44.44 is the mass of the oxygen. Now divide with the AR values. For carbon is 12, for hydrogen is 1, for oxygen it's 16. So you calculate the values. You get for carbon, you get 4.17. For hydrogen, it's 5.56. And for oxygen, it is equivalent to 2.78. Now divide. This is the ratio. It's the ratio of the moles of these three elements. Now the next part, we have to find the simplest ratio. For that purpose, divide with the smallest value. The smallest value is 2.78. Divide with R. Now this will be equivalent to, this is equivalent to 1 ratio 1 ratio 1.5 ratio 2 ratio 1, 1.5 ratio 2 ratio 1. So this is the simplest ratio of the moles of these elements. But this is still not the simplest. This is still not the simplest. So we have to convert this 0.5 into the whole number. For that purpose, you will multiply the whole of this ratio with 2 to make it equal to a complete whole number. So this will make 3 ratio 4 ratio 2. So 342. So empirical formula will become C3H4 and C3H4 and O2. This is the empirical formula. Then part B, organic compound R has the empirical formula CHO and a relative molecular mass of 116. Determine the molecular formula of compound R. So here empirical formula is already given, CHO, and molecular mass of the same is also given. We need to find the molecular formula. So if we remember, there is a determination of the value N, which is equivalent to molecular mass divided by empirical formula mass. Empirical formula is given here, CHO, just find the empirical formula mass, which is equal to 12 plus 1 plus 16. So it is equal to 29. Then MR is also already given. MR is 116 divided by 29. So this is equal to 4. So now multiply this 4 with the empirical formula. 4 times CHO. So this gives you C4, H4, and O4. C4, H4, and O4. And that's it. We have done all the relevant parts of this paper. So I will attempt the remaining parts when we will be covering the relevant topics in the coming weeks. That's it. That's all for today. If you have any question, please let me know.